Hi, welcome to this video. This is a continuation of the C# Beginners series. In our last video, we looked at comments. In case you didn't watch that, I encourage you to watch the previous video before continuing with this video. Today, we will be looking at what conversion of data types in C# is. In C#, it is possible to convert from one data type to another. So say from an integer, we could convert from an integer to a long, from a long to an integer. That is possible. Now, this conversion can either be implicit, it could be explicit, or it could be through helper classes. And we'll look at these three approaches and see what provision we have and in what scenarios this could play. Implicit conversion, this is an automatic type conversion. It is performed by the compiler to convert one type of data to another type without any explicit casting or conversion syntax. So in implicit conversion, it is done by the compiler alone. As a developer, you don't need to contribute any input to cause it to do this conversion. That is the implicit conversion. So it's the conversion in which the user or the developer has nothing to do. It doesn't need to do anything to allow that conversion to take place. Now, it is to be noted that this occurs when the conversion is considered safe and lossless. But first of all, let's just look at what implicit conversion really is. So if we have our project here and we have, let's say, an integer, we call it my int, and the value there is 54. Now, I could just convert this to a long, and I can say my long. I could just, by passing it 54. That would be it. But I could say my int, for example, and the compiler will not complain. Even though this is an integer that I created here, and I'm putting that integer value into a long, my compiler doesn't complain. What is happening is that internally, it converts this integer into a long. You remember an integer has 32 bits, a long has 64 bits. So what it does is, it takes this integer and creates a space for a long which has 64 bits and puts that data into it. And that brings me to the second point. It says that it occurs when the conversion is considered safe and lossless. So let's pick the matter of loss. So if we come back here, it means that I cannot come and say my int is equals to my long. Even though long is a number and int is also a number, so to say. But because my integers have 32 bits and long has 64 bits, it means that if I want to put something that has 64 bits into something that has 32 bits, definitely we'll have some loss. It will not be correct. The data will not align. That is why we need to be careful. Compiler will not allow you to run the application at all. So it's important to know that once there will be loss, there cannot be implicit conversion. Implicit conversion only occurs where there is certainty that there will not be loss. So, for example, something of 32 bits can fit into something of 64 bits without losing any data. So this is possible. Also, it means that if I have, for example, let me create a short, and I call this short, and I cannot put my int here because my int is an integer. It has a space of 32 bits, but short has 16 bits. So it means that if I want to put my integer into short, there is possibility of me having some loss. Because short can only take, for example, up to 32,000, but my int can take more than 32,000. So if I put any data above 32,000, there is likelihood that I'm going to have some loss. So the compiler will not allow this out of the box. So the compiler will not allow this by default. So this is implicit conversion. But when we talk of safety, is, for example, let's say we have, let's just clean this up. Let's say we have a string, we call it boy, and it contains boy. Now, this is a string. I cannot come and say that, okay, so my int is equals to this boy. The reason why is because we don't know what is in the string. So let's say for now we know it is 54. Yes, we know, but the compiler has no way of knowing that this is 54 as at the time it's compiling. So it will not allow this because it's not safe. So because even if it's a number, what if someone puts D? It means that this could throw because how will it convert D into a number? It has no way to do that. It can't convert D to a number. So it will not convert this because it is not safe. This conversion will not be possible because it's not safe. So when it is not safe, or when there is possibility of losses, you cannot convert a data from one type to another. Implicit conversion can only occur when it is safe and there will be no loss of data. It's very important to note that. So let's go back to our slide. So it occurs when conversion is considered safe and lossless, meaning no data loss or precision loss is expected. Also, the explicit conversion is not like the implicit, which is automatic. This is a manual conversion. It involves the use of explicit casting. So it means that, for example, as we were talking of my int the other time, and we wanted to put my long into my int. Now, compiler will not allow this, but let's say we are sure that the value inside my long will always be in the range of an integer. But my compiler will not allow me because it doesn't know that, it's not aware of that. So what we could do is explicitly tell the compiler that I want this to be converted to an integer. So what this will now do is, by putting this, it knows that whatever is inside my long should be converted into integers. So we are giving it, so to say, like a guarantee that whatever is in my long will fit into my int. This is like giving it, telling it, don't worry, there will be no loss of data, there will be no loss of precision, it is safe, go ahead. That's basically what this tells the compiler, and so the compiler doesn't throw an error anymore. So that is the explicit conversion. But I must note that you can't do explicit conversion on from every data type to the other. So for example, let's say as we spoke of my int the other time and this string, I can't come and say I want to convert boy explicitly. This is also not possible because it has no way of guaranteeing what is in the content of boy. It doesn't know, it cannot assure us that, okay, it's fine, this number, there is no way in the world it knows or is sure about that. So that is why the explicit conversion will not work here. So for explicit conversion, it's usually that they are related in a form. So, but you see, a string and an integer, there's really nothing that relates to them. There's really nothing that bridges between them. So that is why you see explicit conversion will not be able to work for this. That will now take us to the third one. So as we say there, you cannot explicitly convert from every data type to the other. So for example, you cannot convert from string to int or vice versa. It's not possible even with the explicit conversion. So now we go over to the last, which is the inbuilt conversion classes. Now, C# has designed approaches to convert from one data type to another where implicit and explicit might not be applicable, using the convert to and the pass method. So we'll look at those two now. So you remember we had tried this earlier and we were trying to convert boy to an integer. We tried implicitly, it will not work. We tried explicitly, this will still not work. The way we can tell it is by using the convert.to class. Now you see, when I press convert.to, you see there are many of them. We have to string, to base 16, base 64 string, to boolean. You can convert to a double, to an hexadecimal. You can convert to an unsigned integer, since for that is unsigned long. You can convert to there are many of them here, which we could always go ahead to check now. But we want to just convert to an integer. And because it's an int, if you remember, long is 64 bit, int is 32 bit, and short is 16 bit. So that's basically what this int 16, int 32, and int 64 really is. So we want to convert this to an integer, and so we can pass boy. And so it's what you are telling is, I am very sure that this data here is actually a string that contains only numbers that falls within the range of an integer. That's basically what this is doing. This is telling the compiler to go ahead, leave this. At runtime, everything will be fine. But we have to be careful with this. So let's say, you see the compiler doesn't complain, it's fine with it. But let me run it now and we see what happens with the compiler. As we see, you see here, it throws an error. It said 54D was not in a correct format. So that is something you need to be careful about when you are using all of these classes, because if you can't guarantee what data is there, it's possible it throws an error, and you don't want your users seeing an error when they are trying to use your application. So, but if we have this removed and we just run it, this will work fine and there will be no issue. You see, everything goes fine and the application stops fine. There is no problem. So that is conversion using the external classes. We also have the second approach, which is using the pass method. So let's take, for example, again, I want to use my int again, and I want to use the int.pass. I could just do int.pass and I pass in the boy. And what it does is it converts this string into an integer also. So either of these two could be used to convert from one data type that is admissible by it. So we can use it to convert it from our string to the integer. This is very important to note, that for the pass method, it majorly works with the string only. So for example, I could have my double. Let me create a double here and call it my double, and I say double dot pass, and I give it the boy, and it will convert that string into a double. This is very possible, and this is something that can be done. So the pass method works on many of them, of the data implicit of the inbuilt data types in C#. So for example, I could have boolean. So let's say my bool, and I could call this my bool, and I can convert, I can pass it, and I can pass the string, which is boy. Which is boy. I can pass it into a boolean. So you could check possibility. You could just, all you just need to do is put in the data types, maybe decimal, for example, dot pass, and you will see you can pass in your string into it and make use of that. So that is the explicit conversion. So here, if we go back to our slide, we see that it is also good to know that almost all data types have a toString method that can be called to convert it to string. So if we come back here and let's say I have a string, I call it my string, I could convert my int to a string just by using the toString method. So many times when people want to convert, or personally myself, when I want to convert strings from like integers and I'm pretty sure it is safe, I could use toString. But when we have something like string again, and let me just call it another string, I could convert it, let's say my bool, I could convert it to string. So you could convert from almost all data types to string using the dot to string method. But you must note that you have to check for the implementation of them. But actually, for all these inbuilt data types, they are actually safe to use. So what this will do is we convert our integer, for example, 54, to a string of 54. So let's get back. So let's go back to our slide. So here we have seen the inbuilt data types and how they can be converted from one type to another, either through the implicit conversion by the compiler, the explicit conversion, or through inbuilt conversion classes that we have, like the convert.to, the parse method, or the toString approach. I hope that this clarifies conversion from one data type to another, especially the inbuilt data types in C#. Thank you, and see you in the next video.